In this video, we're going to look at making your own custom color type and how you can use a function to transform that into a regular color type that something like filled can understand. You can just directly have a color, say magenta, to be of color type, and then filled will understand that. But one advantage of having, say, your own custom color type and then using a function to convert it into a color type is that you can restrict what colors can be used as an argument. Essentially, if you want to be sure that, say, black never comes up as a color in your game, then you can have assurances that when you make a function that only takes a custom color as an argument, it won't take a regular color as an argument, and there's no way, unless the code changes, to have any of your shapes filled black. So the first thing that we want to do is to create our own custom color type. So I'm going to start by making a type called custom color, and a custom color will be either magenta or lime green or teal. So let's make a function that converts a custom color into a color type. Now to do this, we need some sort of way to represent what a custom color is. So we're going to use something called RGB, which is essentially like a color code. It tells you how strong or weak the reds are, the greens are, and the blues are, and it mixes them together kind of like paint in order to get a specific shade or a specific color that you're looking for. So if we go back to our game slot, we're going to make a function called custom color in Elm, and this is going to take one of our custom colors that we've defined above, and it's going to return a regular color, something that filled will understand, and it's going to use RGB to do that. So let's make custom color in Elm. It takes in name of our custom color, and it's going to use a case statement. So depending on which name it sees, it's going to do different things. These different things are the different RGB color mixes to get the color exactly the way we want it. So if this function sees magenta as an argument, then it returns the color codes for magenta. So if we search this up on Google, we go magenta RGB, and we can find the color codes. In this case, we have RGB 255, 0, 255. That will give us the color of magenta that we're looking for. So let's go back here. So RGB 255, 0, 255. If we see lime green, we take the lime green decimal RGB color codes, 50, 205, 50. Lime green, 50, 205, 50. It should be RGB. Then we go to look for teal. We can see the teal color code is 0128, 128. That takes a custom color and returns RGB. Now the thing about RGB is, again, when we look back here, RGB takes in 3 different floats representing the strengths or weaknesses of the colors, and then it returns a color type. So what we get here is we now have a way of taking our custom color and representing it in the color type. So as you can see, if we hit compile, nothing changes. Our function is there, but it's not doing anything at the moment. So instead of red, what happens if we try magenta? If we try magenta, nothing happens because of the fact that we haven't defined magenta without this function. This function is how we define magenta. So we need to pass this custom color name, magenta, to our function custom color in Elm to give us back a color that we can use in filled. Now if we run this, we have a different color. If we run lime green, we'll also get a different color. If we run teal, we'll see yet another color.